Okay, so today we are continuing on with multi-step equations. Just now we will see that there are some special cases when it comes to solving multi-step equations. So remember our steps to solving multi-step equations. Step 1 will always be to distribute. Step 2 is to combine like terms. Step 3 is move the variable over to one side. Step 4 is to add or subtract. And then step 5 would be to ultimately multiply or divide. So we're still looking at the same 5 steps, just now something could happen once we're doing these types of problems. Okay, so solutions to our linear equations, which is what we're solving now, is the stuff we've already been doing, which is when you have exactly one answer, the one solution here. Okay, you also have infinitely real solutions. Infinite real solutions means that it could be whatever value of x. Pretty much. It means whatever you put on the left will always be the same as the right. It's known as the identity. So sometimes it will be using this is an identity case. Okay, so what's your answer? So you do want to know that that identity means you have infinite answers. And there's also a case in which there is no solution, no real solution for your problem. And we will see how that applies to these problems. So remember, there is 3 different ways, and there are examples of all of these within the notes. I believe that there are maybe 7 examples to go over, and there will be ones that have one answer, which is what we're used to. There will be ones that have infinite answers, and there will be ones that have no solution as well. So we will have to be able to identify which one is which as we're solving here. So here is our first example. Remember our 5 steps. Step 1 was to distribute. Well, there's no distribution here. Step 2 is combine like terms. Well, I do have to combine like terms. I have an 8x and a negative 3x on this side. Okay, everything else just drops. 5x minus 2 equals 8x minus 3x. Well, 8 minus 3x is 5x plus 4. Now, step 3, move variable to one side. Well, I would move this 5x over to the other side by subtracting it because it's positive. But what ends up happening when that happens? 5 minus 5 is 0. It cancels. 5 minus 5 is 0. It cancels. And you're left with negative 2 equals 4. And we've never been left with this before. We've never had the case in which our variable cancels out. And whenever our variable cancels out, it will be one of our 2 cases, either infinite solutions or no solution. And what ends up telling us what it is? Well, that's this statement right here. Okay, if it is a true statement, you will have infinite solutions. If it's not true, it will be no solution. So we look at this and it says negative 2 equals 4. Well, that's not right. So this is our case when it's no solution. So no solution is when your variables cancel out, when you move it over to one side, and you're left with something that's not true. Which means if it's true, it must be infinite solutions, right? But we'll see that in another example. Okay, example number 2. Step 1 is always to distribute. So let's distribute. 2 times 4 is 8. 2 times x is 2x. And this side would just drop. Now we have to move our variable over to one side. Well, it's positive 2x, so I have to subtract the 2x. So my other x terms. Well, once again, my variables end up canceling out, and I'm left with 8 equals negative 6. Well, once again, that's not true. So this is another no solution. So notice that what ends up canceling out my variables is when you have 2 of the exact same variable term. You have 2 positive 2x's, meaning it is going to cancel each other out. So this is another no solution or no real solution you would see in a multiple choice. So then here is a longer problem that we would end up needing to solve. Remember, step 1 is always to distribute. So we have 7x minus 3 plus 5x equals 12x plus 6, and we still have a minus 9. Step 2, combine like terms. On the left, I have 2x terms. Remember, it's on the same side, so I keep the same sign. So 7 plus 5 is 12x, and I still just drop down my minus 3. On this other side, I have 2 non-x terms that would be combined. 12x would drop, and plus 6 and a negative 9 gives me a negative 3. Now, move variable to one side. So I have negative 12x, because it's a positive 12x, As you can see, the 12x's would cancel because they're the exact same. You're left with -3 equals -3. Well, now this is actually a true statement, which means you have infinitely many solutions or infinite real solutions. So either way you state it should be fine. So infinite real solutions or infinitely many solutions you may have heard in the past. That would be your answer. So remember, this is the case when your variables cancel out, but now this is a true statement. That would give you an infinite solution. Here is another example. So remember, distribute's always the first step. Copy down everything else. So 3m plus 3 equals 3m minus 6 plus 9 is what I would get when I distributed. Combining like terms. Well, on this right-hand side, I have a -6 with a positive 9 that would combine. So this is 3m plus 3 equals 3m, and -6 plus 9 is a plus 3. I would then move my variable over to one side. What happens, I'm left with a +3 equals a +3. That's true. So this is infinite real solutions. Now, sometimes you don't even need to do all this work. As soon as you combine like terms and distribute, if you look at this line right here, your left and your right are the exact same thing. This is why it's known as the identity. So this statement right here with these arrows is known as the identity. You have two sides that are the exact same thing. This is why it's known as the identity. And when you do, every time this happens, the left is the exact same as the right. Your variables will cancel when you go to move it, and you will end up with a true statement giving you an infinite real solution. So if you can catch that your left equals your right, then you already know your answer is infinite. Then here is another one. Remember, we would distribute a -3 here, not a +3. Copy down everything else. So 36 minus a equals a -8a plus 3a, because negative times a negative gives you a positive, and -3 times -4 will give you a +12. Then combine like terms. On the left-hand side, I have a non-a and an a term. I can't combine anything there. But on the right-hand side, I have two a terms that could combine. So I have 36 minus a equals -8 plus 3 is a -5a plus 12. Okay, remember, then I would move my variable over to one side, so add the 5a. And this time it looks like my variable is not going to. I will have one answer. So this 36 drops. -1 plus 5 is a +4a. And I would just go around solving it like we were yesterday. So subtract this 36. And you end up with 4a equals a -24. Divide by the 4. And you end up with a equals a -6 as your answer. So this is the case when you just do have one answer like we've been doing the whole time. So remember, we do have three different types of solutions. It's no solution, infinite real solutions, or one answer. So we have to be able to identify what's what. If the variable doesn't cancel out, you know you should have one answer. So don't just write no solution or infinitely many solutions. Here is another one to look at. So we would distribute here on both sides. 8 times 4b is 32v. 8 times 8 is 64. 4 times 8 is 32v. 4 times 1 is 4. You would move the variable over to the other side. When you do that, both variable terms cancel, which means it's one of our special cases, and we have 64 equals a +4. Well, that's not true, so this is a no solution. So no solution would be your answer, or no real solutions. And I believe this is our last example. It does look like a nice long one to end with. Let's see what case is it. Let's see if there's one answer, no answer, or infinitely many answers. So remember, first step is always to distribute, and we would distribute on both sides. Remember, on this right-hand side, you are distributing a -5. When you distribute, you should end up with a 4v plus 8 minus 8v equals 6v minus 10v plus 10 minus 2. Then second step is always to combine like terms on the left and combine like terms on the right if you're able to. So on the left-hand side, we have a 4v with a -8v. Well, 4 plus a -8 is a -4v. Drop down your plus 8. On the right-hand side, we have two sets of like terms. We have a 6v with a -10v. Well, 6 and the -10 will give me. And then we have two non-v terms of a 10 and a -2, which is a +8. Now, like I said, if you're really good at catching these things, we have two of the exact same sides. My left is equal to my right, meaning this is an infinite real solution problem, because this is the identity. They're the exact same. But say you didn't catch it, that's fine. You would still go on and you would solve this. You would add this 4v to the other side. They would both cancel. You'd be left with 8 equals 8, which is true, which means you would still end up needing to write infinite real solutions or infinitely many solutions, whatever statement that would be stated. And I believe that is all for today. So remember that this is the case, that we have 3 different types of answers that we could have. One is infinitely many solutions, one is just one answer, and one is no solution. So keep that in mind while doing your work today.